Alright, in the last video I mentioned that we're going to record, I'm going to talk to you about how to calibrate your microscope, find out what your length per pixel is, and where we're going to use that information is in your image J. For those of you who don't know what this is, this environment, this is called Ubuntu. This is Linux, and it is fantastic. If you haven't used it, you should give it a try. Alright, so image J, let's open up a picture. Don't mind what this picture is, but we're just trying to open that. Okay, so that's my picture. We go to Analyze, Set Scale, and here you should tell image J what is the length of each pixel, because pixel does not have any lengths. It's just DPI, a representation of an image to you. We have to know what is the length of each one of these pixels in real world. What is the correlation between them? There's a way to calculate that. So if you don't have fancy software that can do this calculation for you, you have to do it yourself. We're going to learn how to do that ourselves. Alright, so how do we do that? What you're going to do first is you're going to find an object that you can take a picture of. It has to be a small enough of an object that you can put it under the microscope and take the whole view field just by that object. So what I have here, this is the picture that I've taken from a gauge block. What is a gauge block? Gauge block is something that you use, it's used for measurement. Usually it comes with a set like this. I've taken a 0.5 millimeter or 1 millimeter, I think I've taken 1 millimeter gauge block, and I've put it on microscope standing up vertically, so I'm looking at the cross section of that gauge block here, okay, and it measures 1 millimeter. Now most cases it says how much it is, what's the width of your gauge block, but you can also take a micrometer and make a really precise measurement on the length of it. For example, this one here is 2.005 millimeter. This is 1 micron precision on measuring the lengths of this micrometer. It's very precise. Alright, so let's just say you have done that and you've measured it. We have our first picture, which is this one. What is next? What we're going to do is we are going to measure the lengths of this gauge block first in pixels, and then we know that this is 1 millimeter. So you're going to divide that 1 millimeter by the number of pixels that you have in the width of this picture. Right? How do we do that? Now, to do that very nicely, since we don't know exactly where is the edge here, you can see there is some surface damage on this edge because it was an old gauge block, or our picture doesn't show very properly. What you're going to do is, and what I've done is I have processed this image so that all these edges are exactly vertical. Why? Because that will allow me to draw a rectangle like this, and I can find the edge of my sample in average. Okay, so we're using our eye to find that edge, but there are more precise ways to do this, which depends on how accurate you want to be in your measurements. Okay, so this is the processed image which I have made using the original image. You can see the edges are vertical now. Okay, so what is the width of this gauge block in pixels? I'm gonna draw this triangle from edge to edge. Is this the edge? It looks like it is the edge. So it says right up here that it measures 730 something. Where is that? Okay, there we go. On the here, it reports that here, the widths. Okay, what is that? That's my edge, 771 pixels. Alright, so your calculator, one millimeter is 1000 microns. So I'm going to divide 1000 by 771. It'll be 1.29. What is this number? This is how many microns that every one pixel represents. And in my opinion, it's a very precise measurement because you divided 1000 by 771 of pixels. It's a very precise measurement on what should be the width of each pixel. And then you'll go to your, now you can go to your analyze, set scale, to put this number here. What is the distance in pixel? I know the distance, the length of one pixel. So you're gonna put one pixel, or you can do even 1000. It'll do the calculation for you. So let's put 1000 here. What is the known distance? It is 1000 micron. No, 1000 micron. But what is the distance in pixels? 771. So we're done. All right. I want to know what is. Let's get rid of that. I want to know what is the length of this line that I'm just drawing. It looks like it is from one edge to the other one. Okay, so I draw that. I can go to analyze and I can do measure. Control M. It says the length is 982 microns. Okay, that's what it is telling me because I set that as scale. From this point on, the length is going to be in microns, which is pretty accurate, right? It's supposed to be 1 millimeter, but the reason it is not is because this is slightly over or under the location that it's supposed to be, and also this edge is not really well defined. From here to here is different than from this point to the other point. All right. So what is next? Now the problem is this calculation that we did right now is only done for magnification of 5. What does that mean? That means if this picture had been taken in a different magnification, this number, this length that we've calculated, that would have been a different number. Okay, that means you have to multiply this or divide this by the factor that correlates the two magnifications with each other. Added to that problem is the problem that's this: these pictures can be taken at different resolutions of your camera sensor. Okay. I could have taken this picture at lower resolution. That means every one pixel in that low resolution would be probably this big. That means this number would have been gone up. All right. So to do that, to take care of all of those different magnifications and different resolutions, what I've done is I've created this Excel sheet. This Excel sheet will take some input variables from the way that you have taken your picture. Okay, you will put the resolution of the picture here. You select that. This is done in Microsoft Excel, and it's not taking that very properly. It's not letting me input the problem, but there's an arrow that will come down here, and that reads the number of the resolutions that I've written here, and also the objective lens magnifications down here, and it will do the calculation for you how much is going to be your length per pixel. Oh, this is LibreOffice. It's different than Excel. That's why. Alright, I've made it in a way that the arrow will pop up here. Okay, it doesn't do that here, but it doesn't really matter. Okay, what matters is this. You have to take this number, 0.33. This is for 200 times magnification, which means it's the objective lens magnification of 20. And this is the resolution I've taken. You're going to take this number and you're going to put this as length per pixel in your image J. Now I'm going to make this available in the description. You can download it, you can play with it, make changes, but be sure that if you're making changes to it says customize for new setup, be sure that you know what you're doing. So these are the resolutions of the pictures that we're going to take, or the options that you have on your camera, and these are the objective lenses that you have. You might have different magnifications. You can change these numbers. It'll take care of it. And then at the end, you're going to update these numbers that we have here. These are the numbers that I used as my reference. So the first gauge block image that we take, they're going to be here. So 1000 micron was the diameter, the width of the gauge block. 764 was in pixels. Magnification, the reference was 5, and this was the reference resolution. And you will take that and you can update this as much as you want. That's it for now.